In this lab, we're going to be learning how to make a multiplayer space shooter, a la Galaga Space Invaders-esque. It's going to be inside of Photon Fusion and Unity. And now I need to close this. It's going to be awkward because I haven't recorded a lecture in a long time. I'm going to go ahead and start this one off clean with a new Unity project because I need a new Unity project here for me to work in. So you're going to see me set some of this up. In this case, we want to work inside of 3D Universal Render Pipeline, or ERP, because it's fun to pronounce. We can call this MP Space Shooter. It's a fine enough name for it. And then I'm going to click Create Project for that, and it's going to chug for a second. In fact, I'm going to pause recording while it chugs. All right. And once that chugs, that took an insane amount of time for this to set up this project. You'll be presented with your standard Unity view. Now this is going to be a multiplayer game, so we're going to have to set this up for multiplayer services. So I have here in my downloads a slightly old version of the Photon Fusion stuff. So if you still need that, you can go to photonengine.com, go to their SDKs, click on the Fusion button. It'll probably be different by the time you get to this video, and good grief, is this also taking a while? You'll click on the Fusion button here, you'll click on the Get Fusion SDK button there. It's going to load for a second also. That's going to get you to this particular page. You'll click on this button to download, but you have to be logged in for that to download. And I can't remember my password, so I'm going to use an old version of it. When you download it, you're going to get one of these Unity packages, and we've likely done this in class already, but if we haven't, you take those Unity packages and you drag and drop them into the project folder of Unity. You can also double click, but you got to make sure that Unity is open at the time. Once you've done that, you can go ahead and click import for all those things. It's going to take a second to import as well, but this should be faster than the original Unity setup. Maybe potentially. And I just realized I'm going to have to log in anyway, so let me pause this while it imports. All right, so once that has imported, you're going to be presented with a screen that looks like this, and the key part of this down here is this Fusion App ID. That's where I mentioned I needed to log in. I'd forgotten about this part. So I've gone ahead and reset my password. You will not need to do this hopefully, but maybe you will. And once you've reset your password, you can go to photonengine.com/nus slash photon and log in. I'm logged in already, so you can click on Dashboard and you can wait. If you haven't done this already, just real quick, you can go through and say New App. Make sure that for this particular one, you're doing a Fusion app. Give it some cool name. I might just call this one N337 applications and just use the same one. And then the rest of it's actually fine. So you can click Create. And I've already done this, right? And you can see I've got one just called N337. So I'm going to do that. Once you've done that, it will take you back to this page. So you can go ahead and come in here. This is the ID that I want. So I'm going to copy that. And I'm going to go paste that ID into here and hit enter. Once it does that, you're good to go. You're actually set up or you register this application as one of your Photon Fusion applications, and we can close this. Now, there's a whole bunch of stuff in here that we really don't need for this, so we're just going to work in this particular scene for now to start up our multiplayer game. And I'm really hoping my other computer battery, my cheater computer, will have all the source code finished last through this entire video. Okay, so here we are. And we want to make a space shooter a la Galaga or something like that. And the first thing I want actually is some other assets for this. So I'm going to come over here and I'm going to look for um, any game assets, which will be sort of forever memorized in our lives as something that we use for prototyping games, so that we might use for prototyping games. I'm going to click on 3D, and somewhere within inside of 3D there will be a space kit. There it is. Wow, my internet is running slow. Oh, it's because... That's why. Much better. Background downloads are the devil. So we're gonna go find the space kit for Kenny. We're gonna hit download. We're gonna download that. If you want to, I really should become a patron of Kenny at this point because I've done so much. I've used the stuff quite so much. So we're gonna download that space kit. Of course, now I've destroyed my internet speed because it gets mad at me when I try to download anything more than 2 megabytes. Beautiful. So once you download that, go find that in your file explorer. There's space kit right there. I'm going to right click on Space Kit. I'm going to extract it. You can also use extract all in Windows. Mac has some way of unzipping things. Heck if I know what it's called in the moment though. And I use 7-zip, so I'm going to 7-zip that sucker. When you go in here, there's going to be 3 different sets. We want models, and any of these models will work actually. They're all completely fine. But for us, the FBX format is actually sort of the ideal. So I'm going to create a new folder inside of assets and call this models. Since this is sort of a high level project, we can get away with a lot of these high level folders. And then I'm going to go into FBX, and I don't want all of these. That would be a little bit too much for this particular project. So I'm just going to grab a couple of them, and I believe they're all called ship. Let's see, are they? No, we've got terrain, we've got rockets, we've got pipe, we've got machine, we've got corridor. This is not the right one. Good grief. There's no ships in Space Kit. And that's, oh, there are. I just don't know what they're called. Craft. There they are. So we're going to look for craft. Let's grab a couple. These can be whatever you want. I'm going to grab a craft cargo, and I'm going to drag and drop that into models. I'm going to grab a craft racer and drop that in models. And I'm going to grab one of the craft speeders. Beautiful. So now I have 3 crafts that I can bring into my project. So these will be my 3D assets. In fact, I can drag and drop them into my scene to sort of see what they look like, but we're not going to work with them this way. So that's what my craft speeder looks like. Awesome. So we've got our 3 3D assets in here that we're going to be working with as our sort of primary assets for this project. The next thing that we're going to do is we are going to create a blank game object for our player. And you'll see I do this quite often where my root game object for whatever my objects in the game are has nothing really in it to begin with, and I put on it what it needs to have on there, but many of the things become subcomponents. So right click anywhere inside the hierarchy, go to create empty, and we're going to call this player with a capital P. Since we're at it already, I'm going to go ahead and over on the right hand side in the inspector, so way over here on the right, where it's tagged, I'm going to go ahead and tag it as player too, just to sort of make sure. I'm going to zero out its position, so I'm going to set that position to 0, 0, 0 in the inspector as well, so I know it's sort of at my world center. And then I'm going to drag one of my crafts on top of player. Make sure it's directly on top of player. You can see that it looks like I'm dropping it right on top, and that there's an arrow that appears next to it. If it doesn't, winds up there, just go ahead and drag and drop on top of player. So it's a child of player. And that looks pretty good to me. I'm digging this already. So we've got now a player with a craft cargo on there. Awesome. So we have a setup for our game to begin with. Oh good. I like that it sort of picks up my breath. Maybe it doesn't pick up the breath for you. Who cares? So we've got our craft. The next thing we need to do now that we have the player in there is make it so there can be multiple players. And this is going to take a little bit of work. So we're going to work with their prototyping tools inside of Photon. So I'm going to go to Fusion, which is up in the file bar. I'm going to go down to Game Object, Setup, and I'm going to select Add Networking to Scene. This is going to give us like a lot of the basic Fusion prototyping network stuff. So I'm going to run that real fast. And now if I click the play button, you'll see when it runs that I get this to begin with. So we have a place to type in a room name or number and all of these. And if I type start host, I'm going to be sort of presented with the game. It goes through there. It says Fusion is starting up, connecting to clients. And once it's connected, that UI element goes away and we're presented with this view. So I'm going to close that and I'm going to return to this game. So I've got Fusion set up. That doesn't make it multiplayer, but it's the first step to making this multiplayer. So we've got Fusion there, and that has added prototype network start and prototype runner. Now, any object that we want to be a multiplayer object in this game, and now that I'm looking at this, I just realized that my ship is not zeroed out, so I'm going to set its X and Y and Z to 0, 0, 0. That will look a lot better for me. Any object that we want to be a multiplayer game object to have its location synchronized across games so that it appears in the right place at the right time for every player has to be a network object. So I'm going to select the player now, and I'm going to click Add Component, and I'm going to type in network object until I find that. That's going to come up here. When it says this object hasn't been baked yet, that just means that you have to hit Control S to save your scene. And that will bake it for you. So now it's a network object. I actually don't think I do player damage in this one, so it's not something we have to worry about in this case. So let's go ahead and make this actually a prefab. So I'm going to return down in our project settings down here in our project folder. And I'm going to make a new folder inside of there by right-clicking and saying create new folder. And I'm going to call this prefabs. Into the prefab folder, I am going to go find my player object, and I'm going to drag and drop it here into the scene or into the prefabs folder. And I'm actually going to delete the player object where it stands right now in the game. So if I click play, you'll just see there's nothing there in my game. Wow, it really doesn't want to play. Sort of anti-play today, huh? Slows me down quite a bit. There it goes. Cool. So nothing in the scene right now as a B. Cool. The next thing we're going to do is make it so that multiple players could potentially appear in the game. Though we're not going to test it right now because too much work. I'm going to have to make a build for that, and I don't want to do that right now. So we're going to make it so multiple players could appear in the build. The way we're going to do that is by going to prototype network start. No, prototype runner. Where is this? Oh, maybe I don't have the spawner in here. Okay. We're going to go to prototype runner, and we are going to add a few new components. So I'm actually going to drop these two down by clicking these so I can find this add component button. And on prototype runner, I'm going to hit the add component button, and I'm going to type in player spawner prototype. So there's other ways to do this, but this is going to work for us in this situation. This is a built-in class that Photon has developed for us. It might not be the class we want to use in the end, right? Because it's got the word prototype, but it's going to do the job for us when we're still sort of learning the ropes. We're going to add another component, which will be the spawner. If I could type, good grief, the player spawn point manager, and that should be everything because they should know about one another by default. Good. And the last thing we're going to do here is here under the player spawner prototype, it says player prefab, player prototype, nothing. That's a prototype that Fusion has made for us. We want our player. So I'm going to drag player from the project onto that player prototype. And that's great. So now that's set up. The last thing we're missing here before we can spawn a player is we need a point where the player would begin. So over here in the hierarchy, I'm going to right click. I'm going to go to create empty. I'm going to name this spawn point. We in fact might make multiples of these in the end. I'm going to make sure it's at position 0, 0, 0. And then I'm going to click add component. And this time I'm going to select player spawn point prototype. So I could type that in. That makes it a spawn point. You'll note it's a spawn point because by default it gives you these awful looking orbs. So that's there. That's all set up. And if we go back to prototype runner and we go click on find spawn points, it's going to find one spawn point for our game. That means that we can now go click the play button. We can click start host. We can wait for the host to begin, and we'll see our player appear there. So we have this. This would actually make multiple players for multiple scenes now. So we're on our player. The next step in this process for us is to make it so that the player can move around. an exciting time for all of us. Exciting being that we're going to have to write a bunch of scripts now soon, so please look forward to it. And I want my prefab cheater open. Beautiful. Yeah, so we're going to wind up adding a rigid body to it and a whole bunch of other stuff. Cool. So we want to be able to move this player around. Let's go to our prefab. We're going to find that player prefab in our prefabs folder where we created it. We're going to select it and we're going to add a bunch of new stuff to it now. So with it selected here, you could even, if you really want to be cautious about this, double click on it to open up that prefab. Make sure that root is selected. We're going to add a bunch of stuff to it. So we're going to add a new component and it's going to be a rigid body. Normal rigid body. Once you've added the rigid body, go ahead and deselect use gravity. So turn that off. And then beneath rigid body, we're going to add component. We're going to add something called a network rigid body. Ooh, I hated that. I was really unhappy with that. Great. And I'm going to create that network rigid body. This is giving the capability for us to automatically sync the position of this object inside the game. So network rigid body will do that syncing for us, and it's based off this rigid body. So it actually does some prediction. It tries to predict where it might be on another player's computer, just in case there's a little bit of discrepancy between each computer. Sort of smooths over the differences as the simulation goes along. Now, for the smoothing to happen, you have to have something that is not the root element be tracked, and that's called the interpolation target. We can do this in a number of ways. Oftentimes, when you look at a system, it will be a model that is a child of that empty game object. So that's one way you can see. You saw I dragged and dropped craft over there. Another way this can be done, however, is by right-clicking on player, going to create empty, and calling something I called it INTR target. And it's the same concept. It's just this empty game object that we set as the interpolation target. So INTA target, I select the player root, and I'm going to drag that target on top of the interpolation target there. And now you're good to go. So now this person here, if we moved him around in some place, their location would be synced across all computers. The next step in the process is to actually write the code to make this ship move around. So we're going to come back to our assets root folder here. We're going to right click, we're going to go to create C# script. In this C# script, we are going to name, or not C# script, good grief. I'm going to just delete that one. We are going to make a C# script, but first we need a folder. So we'll let my computer be slow as it likes to be. So we're going to right click, we're going to go to create, we're going to go to folder, we're going to name this folder scripts with a capital S. Inside of that folder then, so double click on that folder, we're going to right click, we're going to go to create C# script, and we're going to call this player ship, capital P, capital S, no spaces. Great. And then double click on that script. It's going to launch Visual Studio 2017, or a Visual Studio, I suppose. And we can move on to the next bit here once it loads. If it kicks you over to something and you're at IU in a specific, you can log into Visual Studio by using your IU credentials. You log in with at iu.edu, not IUPY, and that will kick you over the central authentication system. You can use your school password. Beautiful. So we've made a new script called player script or player ship. And I need to open up my cheater one. The first thing we're going to do here is we're going to import Fusion. So right after Unity Engine, we're going to write using Fusion, colon. And we're going to change this class from a mono behavior to a network behavior so that it has all the capabilities of a multiplayer game system. The first thing inside of the class that we'll do is create a private rigid body with a capital R, and I always name my rigid bodies RB because it makes me think of rhythm and blues and beautiful music. And then inside of start, we're going to get a reference to that. So RB is equal to this dot get component rigid body, open and close parentheses. This is going to allow us, as we write this code, to apply forces to the rigid body to move our spaceship around. Be very important for us. Now, in terms of moving our spaceship around, we're actually going to have to hop out of the script in just a second. But while we're still here, I'm going to delete this update because we don't use that one inside of Fusion. Instead, we're going to write a new method called override space public space void space fixed update network. Beautiful space, and we can get rid of the space dot fix update network. No one cares about that. Wonderful. Now, there is a way in Unity to get input using our input system, but that does not network the inputs for all users. So we're going to have to now go get our input in the way that Fusion prefers for us to write inputs, which I find to be just a little bit frustrating. But we will make our way through it. Oh, did I cheat this one? Maybe I did. One second. All right, so we're going to return to Unity, and we are going to go to our scripts, and we are going to wait for just a second. We're going to right click in the scripts. We're going to create a new C# script. I'm going to name this one Space Network Interactions. Capital S, capital N, capital I for those three. It gets really mad at me when I do those things. Now I have to wait for that to load so I can double click on it to open it up. And in fact, we're going to go digging here for a second. So we're actually going to go into Assets. We're going to go into Photon. We're going to go into Fusion. We're going to go into Scripts. So Assets, Photon, Fusion, Scripts. We're going to go into Prototyping. And yeah, that's the one we're going to go nab. We're going to go into Input Behaviors and double click this to open it up. Awesome. So there's no good way to do this. I spent a very long time to try to find a simple way for this to work for you all, and there isn't. Because the only way you can get input is by extending this thing called iNetworkRunner callbacks, which is going to require us to write all of this code right here, even though we don't need it. So we're going to work our way towards that, and then when we need this code, we're just going to do a quick copy and paste and work that way. All right, so to begin with, we're going to need Fusion and Fusion.sockets. In fact, I'm just going to copy those from there and paste them right at the bottom inside of our new script that we made called Space Network Interactions. So using Fusion and Fusion.sockets. Down here, where we have our public class, ours will be Space Network Interactions, you'll see that it actually extends two things now, Fusion.behavior and iNetworkRunner callbacks. So we're going to copy that. And we're going to replace the mono behavior with those two. So those two have been replaced. It always gets mad at me for these. Yeah, and this is why, like, see if we need all of these. So we're going to get those next. So next, we're going to come down here and we're going to copy, instead of input behavior, all of this. All of it. So everything from public void on input missing all the way down to the closing parentheses. For me, it will be line 93 for on-host migration. I'm going to copy that, and I'm going to remove update here and paste all that in and save. Once I've done that, yeah, and we'll get those. Once I've done that, it becomes a little bit happier, but it's still not quite there. And I'm missing one. I don't know what one I'm missing that's making it unhappy. I got all of these. We might just put that one in there. Awesome. Cool. Two more things we need to do here. It looks like it uses a different system. Yeah, so instead of system.collections inside of Space Network, we're going to use just system. And that's going to fix the error that we saw down here. And now we're going to come in here and we're going to create our on input. All right, so I'm going to copy this line of code. And this is going to be our first line of code inside of space network interactions. And I'll close that line there. Great. And now that I have this line in here, we're looking pretty good. So this is a long-winded way of saying we need all these functions, but they don't need to do a damn thing. They just need to be here for the script to be able to run. And I have some real strong feelings about that, but I have real strong feelings about two things in my life. So I guess it's better to have strong feelings about something than nothing at all. Great. So, and this is going to bother me too, actually. Now, if you've been in my class, there's a chance too that I've just had you use this default one. I think that's fine, but it doesn't show you how to do your own keys. And that's why I want to go through this process of making your own keys, even if it is sort of onerous to do. All right, so now we're going to come to here, and I'm actually going to pop this window out and bring it over here so I can reference it as we talk through it. And the first line of code inside of on input is going to be var framework. And, oh, actually, no. Even before then, we need to create something new. So we're actually going to scroll to the very bottom here and I'll put our cursor at the very end of this class. So we're going to work outside of this class. So make sure there's nothing else at the bottom of this class now. And we're going to make a new class. It's class like at the very least. We're going to write public space struct space. I call this space input colon, which is an I network input. All right. This is where we're going to put all the variables that represent the input for your game. So do you have a forward button? Do you have a backwards button? Do you have a fire button? Do you have a jump button? Do you have a control stick that's controlling your look direction? Do you have a second control stick that's controlling, I don't know, your parry direction, whatever it might be? If it's an input into your game, it has to go into this struct in some way. So I have a number here, some of which that I don't actually need. So we're going to start simple, and we might come back to here and edit it as we move forward. The first thing we're going to create in here is a public vector3, which is just three numbers that represent a direction in space. And surprisingly, it's called direction. So what is our input direction? So we're going to make a vector3 that represents in what direction are we trying to push this player. And then beneath there, I'm going to make a public const int fire equals 1. That will be our fire button. And beneath there, I will make a public space network buttons. And this is just a struct that sort of stores some of these inputs. So these are the inputs into my game, right? It's a relatively simple game. Left, right, shoot. That's what we're going to be making in this game. So we don't need a lot here. You could see that if I'm making like a fighter game, though, that I'm going to have, like up, down, left, right, high kick, low kick, medium kick, like all these different inputs for a particular game have to be stored in there then. Great. Now that we have that, we can come to our very top line here in our on input, and we're going to make our input again. So var my input is equal to new space input. So we made that space input down here, and we're making a new one of it here. So this will be the thing that will store what buttons are being pressed on this particular frame. All right. If input dot get key, I have a much better way of doing this. I'm scared to try it, but I think it will work. Let's try it. Instead of input.getKey, we're going to say my input.direction. I'm going to regret this, I know already. Z is equal to input.getAccess we want to do left and right here, so that would be horizontal. We're still working with the old Unity input system because, oh my gosh, I don't want to also walk you through doing the new Unity input system, which would slow us down once again. So that's going to get our left and right. So the direction z is equal to our left and right. Um, yep. And that should work with both our arrow keys and our WAS keys. And then finally, we're going to do our fire button as well. So my input dot buttons dot buttons with a capital B. Maybe. Did I have a capital B for that? Oh, I did. Yeah, buttons with a lowercase b dot buttons dot set, capital S for set, definitely. Space input dot fire, comma, input dot get key space. In this case, we're just looking to see if the space bar is held down. There's also get buttons, and I think jump it would be our there, but I'm just going to hard code the space in this case. Finally, we say input dot set my input. So this is getting input. This is getting input from the user. This is getting input from the user. This is setting the input. This is also setting the input. And then we're kind of sending this along. This is a long-winded way of saying if you want your own custom control schemes, it's going to have to be in something that implements iNetwork runner callbacks. It has to be inside of the onInput callback. And it has to be setting up an iNetwork input struct, which we can see a simple variation of here. You'll get better at this over time. There's some good docs on this if you're interested in reading docs as well. But this is a simple input for us to work on. This should work. And gets us ready to return to playership. So now we're ready to get input for our playership. And to get input for our playership, we go to our cheater. There we go. First write if get input space input. It's inside of the upper lowercase and our less than and greater than. So if input.get space input, open parentheses, out space var space input, double equals false, return. Okay, so what this is doing is getting the input from the user, putting it in a input var. Also, if this is not the current player, it's a remote player, leaving this script. All right, so essentially it says if I'm not allowed to get input for this particular object, I'm not even going to run the rest of this code. I'm going to skip the rest of this code because it's not pertinent to me. The people who are allowed to run it are the people who are controlling that particular character. So if I'm playing, I don't know, some sort of multiplayer shooter, it's my character. I don't get to run scripts on the other players' characters. That would suck if I get to move them around. Awesome. Okay, so we need to know what buttons are currently pressed and released for this to work. Actually, we don't need to right now, so we're going to skip over that. Vector 3 move is equal to new vector 3. I don't think I actually need this particular jump, but I'm writing it out, so we may as well write it. So I'm going to make a new vector 3. Move dot x, yeah, this is where it got weird, equals input dot direction dot z. Let's actually just fix this right now, because then, whatever, we're just going to leave it. RB dot add force move times 10f. We're going to leave it for now and then fix it in a second. Okay. This technically is our speed, by the way, and we might pull that out into a speed variable. Great. All right, so we've gotten to input, and we now have this fixed network update. Let us hop out, return to here, and hope there's no errors in our scripts. Gonna wait for them to compile. It used to be this little thing in the corner, which was kind of nice, and then it got too heavy, I suppose. We're gonna go to scripts, and we're gonna attach player ship to our player if it isn't on there already. So player ship is now attached. Beautiful. And then I'm gonna go back to my main scene, and I'm gonna go find my prototype runner. I'm going to attach my space network script to it. So we're gonna drag and drop that onto the prototype runner. So now that's also in there. We can get our inputs. Let's go ahead and give it a try real fast. I'm going to click the play button. I'm going to click start host. And I'm going to get a beautiful error. Errors are wonderful. Input key named space is unknown. Fascinating. What's different between what I wrote? Oh, good grief. Here it's not space, it's key code dot space. So we're going to come back to line 14 where we've got space input dot fire input dot get key. Inside the parentheses for get key, we're going to write key code dot space. There we go. Save that, come back, let Unity do its compilation. Let's try that again, start host. Cool, another error. Object reference not set to an instance of an object, fixed not correct date, player ship, line 27. Player ship, 27. Key component, rigid body. What? Player has a rigid body. Player ship is attached to that. Why might we not be seeing rigid body? I'm gonna pause to debug this. Alright, so that actually wasn't an issue, but it was an issue. The way to fix that particular error is to change the word start here inside of player ship to awake. And we're going to save that. I'm going to get rid of that print as well. We don't want that there. Save that, come back to Unity, let it compile. Really let it compile. Cool. If we click run, and then start host. Once we load in as a host, we can hit left and right to move our character left and right. Or A and D will do the same thing, or joystick technically, but I don't have a gamepad connected to this. That character is actually bothering me just a little bit, so I'm going to live in front of you go over there and adjust its drag a little bit so it doesn't just float forever. So I've selected the character, I went to its rigid body, it says drag to 5. I have no clue what a drag of 5 feels like, so we're going to find out here. Maybe it feels good. Maybe it's a little bit too strong. I'm going to bump it down a bit and then we'll move on. Great. Okay, so now we have a player, and this would actually give us a multiplayer system now with multiple players coming in, but I'm going to wait till the next video, I think, to showcase that, or at least later in this particular video. So player, it's moving. Cool. Let's get enemies next. I think enemies would be great and wonderful. So to make enemies, what we're going to do is we're going to essentially create an object that is further back from this character here. So somewhere back here, and it'll just be an invisible game object that will create enemies and then send them on their way that way. To create that first initial object, we're going to right click inside of the hierarchy here. We're going to go to create empty. We're going to name this game object enemy spawner. Now we probably want to just quickly zero this out for now, and then we can pull the enemy spawner this way. So it's pretty far back. Mine is at 15. I have no clue if that's a good amount of far back. Let's actually put it up to 20. We'll see what 20 looks like for now. So we're going to pull that enemy spawner back. And then the next thing that we do is we make an enemy. To make an enemy, we're going to go to game object, create empty. We're going to name it enemy. Not essentially a necessary step, but as always, I zero my positions out on those guys because I find that so many things go wrong if they're in weird positions for me. And just like I did with my player character, I'm going to go into my models and I'm going to find something that's good for an enemy, maybe the racer, and I'm going to drag it onto that enemy object so it's a child of that object. Cool. With the enemy object selected, I'm going to hit add component and I'm going to add a rigid body to it. I'm going to turn off its gravity. I'm going to hit add component. I'm going to add a network identity. Was it network identity? Oh, network object. I'm going to add a network object to it. I'm going to hit add component again. I'm going to add a network rigid body. So many things. I'm going to save that so that's set up. And then the last things I'm going to do here is I'm going to go up to enemy and I'm going to change or to go click on the tag. I'm going to go down to add tag. Where this list is empty, I'm going to click the plus button. I'm going to type in enemy for an enemy tag. I'm going to return to my enemy component now. So I'm going to click on the enemy game object in the hierarchy, go click on tag again, and select enemy so it's well tagged. So there's my enemy. I don't want it to be in the game right away, however. So I'm going to go ahead and go into my prefabs, drag that enemy into my prefabs, and delete the enemy that I have. There's actually one thing I messed up with enemy that we will get to in a second. Let's return to enemy again. Now I want the forward direction of this to potentially influence what direction the enemies are moving on. This blue arrow we can think of as the forward inside of Unreal, or not Unreal Engine, inside of Unity. So I'm going to rotate this sucker 180 degrees actually. And I'm going to start just that way. So not perfect, but if hey, I'm pressing the wrong buttons. That's not great. That's not cool at all. Oh, it's because we're in World Transform. How do I change that? Local. There we go. So I'm going to change this this transform from global to local so I can actually see what my local rotations are. And then I'm going to just sort of get that sucker. I mean, it's going to make perfect sense if I just hit Y of 180, but I wanted to show you how you can rotate visually as well. Cool. And then I'm going to go back to global because I kind of hate local transforms. But now I have that transformed the way I want it to. Great. So there's my enemy spawner. Next, we're going to make a script that spawns enemies. Very exciting. So I'm going to go into scripts. I'm going to right click. I'm going to name the scripts. I'm 90% certain I could just call it enemy spawner because I've written this 1,000 times. Right click, go to create, C# script, enemy spawner. We're going to double click on that script, open it up beside our code editor. Cool. And this is using Fusion. And this is a network behavior. And this is going to do something on start. Let's actually do this on awake. So on awake, we're going to invoke repeating spawn enemy, which is a function that we have not yet made, comma outside of those two quotes, 1f, comma 1f. Is this ideal? No. So this says wait 1 second and then invoke this function, and then every 1 second afterwards invoke the function again. We don't actually need the update function, so I'm going to delete that function. We're going to add a void spawn enemy, which is that thing that we just mentioned up there. Cool. And before we do that, we actually need to know what to spawn. So I'm going to put my stuff right up here. So right in between the opening thing for the opening curly bracket for enemy spawner and void awake, we're going to make a public space game object with a capital G and capital O space thing to spawn. This could also be enemy to spawn. Let's actually call that enemy to spawn. Great. And then down inside of spawn enemy, this is a hack, but it works. I think that my awake might have solved this problem, but don't spawn if not connected. So that's a quick hack to do that. Cool. And we are going to spawn our enemies sort of in a random location. So we're going to say vector3 spawn position is equal to this.transform.position. So wherever the object is in world space that this is at, that's where we are. And we're going to change that x position. So spawn position.x plus equals random.range, just range, not random range, random.range between -3f and 3f. So you can imagine this as this is where our enemy spawner is located if we were to represent it as a point. And we're saying, hey, so we're going to take that point and then take a random point that's either up to -3 away or +3 away. So this will be our new point that we're going to spawn at. So that's what we're doing there. Old point, new point, within some range of 6 or 3 to each side. Beautiful, huh? Cool. And we're going to say runner, which is our network runner actually, dot spawn, thing to spawn, comma, spawn position, that position we just calculated, which is at the y and z of our spawner, and then a sort of offset x, comma. I should not want to do Cartesian dot identity. I'm going to do this dot transform dot local rotation, and that's going to help me write my next script. I'm almost certain. Oh, and it's not called thing to spawn anymore. It's called enemy to spawn. Great. So we're going to save that. We're going to return to Unity. We're going to let that compile. And we're going to go to enemy spawner. And we're going to attach this enemy spawner script to it. So there it is. It's going to say, hey, this looks like it's a network thing now, so now it needs to add network object. We're going to do that. And then I'm going to quickly save the scene to bake this object. And we're going to give this a quick run. And oh, to goodness, oh no, it won't work. Cool. So with that added, it'll say enemy to spawn. I don't know what that is. So we're going to go to our prefabs. I'm going to select enemy spawner, and we're going to drag and drop enemy to spawn on top of there. Do we set this up as a network object? Yes, but we didn't set up as interpolation, so we'll fix that in the next step here. Let's just see if it's working for now. All right. I'm going to click Start Host. And we'll see that we are creating enemies. And in fact, if I hop out into my scene, we can see that we're creating them sort of in a random amount here. This seems to be the limits upon which they are done, which means that for my game I might increase that 3 and -3 a bit, but that works for now. Awesome. What's the name to fix on player? I'm going to go double click on enemy. You'll see that the enemy, since we're going to be moving in a second, it needs an interpolation target. So right click, create empty, intr target, click on enemy, drag and drop that onto the interpolation target. Great, that solves that particular problem. Do we have enough time to get enemy moving? We're close, but I think I'm gonna do a little bit of enemy movement script as well. All right, so we're going to go to our scripts because let's get this enemy moving towards us. We're going to right click on inside the scripts. We're going to go to create, C# script, and we're going to name that particular script, surprisingly, enemy with a capital E. Double click on that to load it up. And this one's super simple, so yeah, I'm glad I got to this point. This is a fusion object, so using fusion, if I could spell fusion, using fusion, enemy as a network behavior. I'm going to change this to awake again because I find that awake is working much nicer with us. Two things we're going to do here. We're going to do a public space float space speed. And then we're going to do a private space rigid body with a capital R space RB because rhythm and blues is great. Inside of awake, we're going to write RB is equal to this dot get component rigid body. And then beneath there, we'll do RB dot add force this dot transform dot forward times speed. So we're going to say how fast do you want to go and in what direction do you want to go. So whatever way the enemy is facing is the what direction I want to go, and that's how fast I want to go. So let's save that. We're going to return to this game. We're going to attach the enemy script to the enemy by dragging and dropping it onto enemy or clicking add component down here and typing in enemy. We're going to give it a speed higher than 0. So I'm going to try a speed of, let's try 60 first and see what happens. Then we're going to click run. We're going to click start host. Are they moving? I guess we'll find out. Yeah, they're moving very slowly, but moving they are. Look at them go. They're also way offset from their center point, and that's very bothersome to me. So we've got our characters moving, and their forward is away from us. I also don't like that. That's annoying. You want to cheat? I'm going to cheat this one real fast. I don't really want to cheat it, but I don't know why my forward is wrong. Why is my forward wrong? Let's set a rotation for enemy spawner to 0 and try that before we specifically try to cheat. No, they're still moving in the wrong direction. Okay, we're going to cheat on this one then. Inside of prefabs, we're going to go find the enemy, and we're going to set speed to -100. The negative is the important part here. That should do it for us. Oh no, but now they're facing the wrong way. They're still flying backwards. Enemy spawner, rotation Y 180. Will that make them fly the right way? This is with me having a cheater thing, but if you do like just small little things wrong, they come out different. And such is the way, huh? Now they're flying the right way. Beautiful. So if we look at the game, this is what it looks like. Let's quickly adjust that camera, I think. I'm going to go to my main camera. I'm going to pull it up a little bit, and I'm going to rotate it down ever so slightly. All right, that's looking pretty good. So now we've got our enemies coming in, we've got our player moving left and right. It's essentially every single video game we've ever played in our lives. Now this is technically networked. You're going to have to trust me and believe me, and I hope that I'm not lying to you about that. But that's where we're going to end this particular video. In the next video, what we're going to do is we're going to work on shooting bullets from the player, having those bullets collide with the enemy, and updating a score when the enemies get hit. That's our goal for the next video in this series.